Hi guys, welcome to an academic KCET YouTube live session. Myself Sharif. In this particular video, we will discuss the PYQs of KCET and COMEDK matrices and determinants part 4. This is the last part. I'm done with all the questions. Some 21, 22 questions are left out and remaining COMEDK questions are left out. Right, let us start guys. Question number 76. I'm supposed to find the values of A and B. See, actually A inverse is equal to 1 by determinant of A into adjoint of A, right? This is 1 by determinant A into adjoint A. So if I take suppose 1 tan, okay, let me find out here. A inverse is equal to A inverse is equal to 1 by determinant of A into adjoint of A. Right, now you get suppose matrix 1 minus tan, okay, and tan and 1. If you want to find the inverse of this, 1 by determinant of this is equal to 1 plus tan square into adjoint. Interchange the diagonal elements and change the sign of other elements. So this is minus tan will become plus tan, plus tan will become minus tan. This 1 plus tan square is 6 square, and then 1 this is tan minus tan, this is minus tan. Interchange the diagonal elements, change the sign of other elements. This is minus tan, this is plus tan. Okay, 1 by sec is equal to cos, so this is cos square. Okay, and then minus tan into cos square, and then tan into cos square, and then this is sec square. 1 by sec square is cos. This is cos square theta. Okay, now right now if I multiply this, it's equal to matrix. Sorry guys, by mistake I deleted, I erased. A inverse is equal to, let's say if you have, it's a matter of 30 seconds, 1 tan minus tan, this is 1. If I want to find the inverse of this, 1 by determinant A into adjoint of A. A inverse is equal to 1 by determinant A into adjoint of A. This is determinant is 1 plus tan square, okay, into adjoint. That is interchange the diagonal elements and change the sign of other elements. This is 1 1 minus tan will become plus tan will become minus tan. Okay, now if I multiply this question becomes, this is 1 minus tan, okay, and then this is tan theta 1. Inverse of this will be equal to 1 by sec square. Okay, 1 plus tan square is sec square into you have 1 tan theta minus tan theta and 1. Okay, and that's equal to right side matrix will be equal to A minus B B A. Now if I multiply this, this will be equal to 1 by sec square. Okay, first row first column, this is equal to 1 plus tan square. Okay, first row first column, first row second column, tan minus tan is 0. A inverse is equal to 1 by determinant A into adjoint of A, right? Right, now if I substitute 1 by determinant A into adjoint of A, okay, this becomes 1 minus tan theta. So tan theta and 1, this I'll keep as it is. A inverse is 1 by determinant A into adjoint of A. Interchange the diagonal elements, change the sign of other elements. So if I change the sign of other elements, this fellow is actually, according to the question, this is 1 minus tan, this is plus tan. So this is 1, interchange the diagonal elements and change the sign of other elements. This should be plus tan, this should be minus tan. Okay, so this is 1 minus tan plus tan, this is 1 plus tan square is sec square, into you have matrix 1 tan, okay, minus tan and 1. And then this is equal to right side, you have A minus B, BA. Okay, 1 by sec square I'll keep as it is. Now if I multiply first row, first column, you will get this as 1 plus tan square. First row, first column, first row, second column will be equal to first row, first column, first row, second column is tan minus tan. A inverse is 1 by determinant A. What mistake am I doing? 1 minus A inverse is 1 by determinant A into adjoint A. Determinant is 1 plus tan square. Adjoint is interchange the diagonal elements and change the sign of other elements. Finding the inverse of this, right? Sorry, I'm finding the inverse of this matrix. 1 tan minus tan. Okay, so adjoint of this should be equal to 1 minus tan and this should be plus tan. Okay, now if I substitute, this will be as it is. This should be equal to 1 plus tan minus tan. Okay, now let us multiply. First row, first column, you get 1 minus tan square. Yeah, 1 minus tan square. First row, second column, minus tan is minus 2 tan. Okay, second row, first column, tan plus tan is 2 tan. Second row, first column, second row, second column is minus tan square plus 1. Okay, and then this is equal to matrix. This is A minus B, B and A. Right, now if I multiply, this is equal to cos square into 1 minus tan square minus 2 tan. 1 by cos sec is equal to cos. Again, this is equal to 2 tan. 1 by sec is equal to cos, so this is cos square. And 1 minus tan square. And 1 by sec is equal to cos, so this is cos square. Is equal to right side matrix will be equal to A minus B, B and A. Right, now if I equate, this is equal to cos square minus sine square. Tan into cos will be equal to sine. Okay, and then this is minus sine by cos, right? Sine 2 theta, 2 sine theta cos theta. Right, again this is equal to 2 sine theta cos theta. And then this is cos square minus sine square. Cos square minus sine square. Right side you will get this as A minus B, B and A. Okay, now if I equate, A is equal to cos square theta minus sine square theta is cos 2 theta. And B is equal to 2 sine theta cos theta is sine 2 theta. A will be equal to cos 2 theta, B is equal to sine 2 theta. Answer will be option B. Right, let's move to the next question. What is A power n? Okay, first I'll find out A square. A square is equal to matrix 1 2 0 1. Here also matrix 1 2 0 1. First row, first column will be equal to 1 plus 0. First row, second column, you will get 2 plus 2. Second row, first column is 0 plus 0. And then this is 0 plus 1. This will be equal to 1 4 0 1. Okay, let me find out a cube as well. A cube is equal to a square into a, that is 1401 into this is 1201. First row, first column, you will get 1 plus 0. First row, second column, you get 2 plus 4. Second row, first column, you get 0 plus 0. Second row, last column is 0 plus 1. So I get this is 1601. Isn't it, guys? So this is equal to 1, 2 into 2, right? 2 into 2, this is 0, 1. And then this is equal to 1. 6 can be written as 2 into 3, 0, 1. No, Divakar? Yeah, it should be C, Shubham. Shubhank. This is 1, 2, n. If I take, suppose, similarly, a square, a cube, a power, a cube, a square, and if I take a power n, this fellow should be equal to become 1, 2, n, 0, 1. Answer will be option C. Right? Let's move to the next question. The number of distinct roots of this equation in the interval, closed interval, minus 4, minus pi by 4 plus pi by 4. So you get determinant equal to 0, right? You change C1 to C1 plus C2 plus C3. Add all the columns. You change C1 to C1 plus C2 plus C3. This is sin x plus 2 cos x. Even this fellow is sin x plus 2 cos x. This is sin x plus 2 cos x. This is first column. Right. Second column will be equal to cos x. Okay, and then this is sin x and cos x. Okay, and then this is cos x and sin x. In the first column, I'm going to take common sin x plus 2 cos x. Okay. So this is equal to it. I'll try, Mahesh, not all, Mahesh Kuti. Not all, dude. I'll try my best to complete. Most of the things we have completed for KCET. You can watch the recorded videos. I have YouTube videos which I have done. Most of the things we have covered. Only remaining little first year is mentioned, left out. Anyways, in my next session today only, I'll do the most expected MCQs. In my next session, next two sessions are there. Today's live sessions are there. Do attend that. 1, 1, 1. If I take outside, this is cos x. This will be sin x and cos x. And so last column will be equal to cos x and sin x. Alright, now this is not going to help you out. You don't get interval in minus pi by 4 plus pi by 4. If I equate this to 0, you will get sin x is equal to minus 2 cos x. Okay, now I can write this as sin x by cos x is equal to minus 2. Tan x is equal to minus 2. Right, this is not going to help you out. Now this is equal to determinant of, if I change, suppose this is equal to determinant of, if I change R2 to R2 minus R1, first row is 1 cos x, 1 cos x, and this is also cos x. Change R2 to R2 minus R1 and change R3 to R3 minus R1. Okay, R2 minus R1 is 0. Sin x minus cos x. Sin minus cos, this is 0. 1 minus R3 minus R1 will be equal to 0, 0. And then this is sin x minus cos x. Right, now if I multiply, use the triangle property, this is sin x minus cos x, the whole square is equal to 0. Sin minus cos the whole square is 0 means obviously sin x minus cos x is equal to 0. From this sin x is equal to cos x, sin is equal to cos means x should be equal to pi by 4. Sin is equal to cos, x is equal to pi by 4. Number of distinct roots, real roots is 1 only. That is only x equal to pi by 4 will satisfy. Let's move to the next question. Question number 79. If alpha, beta are the roots of this equation, what's the value of the determinant? If I change suppose C1 to C1 plus C2 plus C3, right? This is alpha plus beta plus gamma, right? Even this is alpha plus beta plus gamma. Alpha plus beta plus gamma. Second column will be equal to beta gamma alpha, gamma alpha beta. Okay, now this is of the form ax cube plus bx square plus cx plus d is equal to 0. If you compare a is equal to 1 and b is equal to 0, sum of the roots alpha plus beta plus gamma is equal to minus b by a, which is equal to 0 because b is 0. So this is 0, 0, 0. Beta gamma alpha beta. All 0 property, this should be 0. Answer is option B. Alright, question number 80. If n is a non-negative integer, what is the value of a power n? First, I'll find out a square. This is 1011 and this is 1011. So multiply first row, first column. This is 1 plus 0. First row, second column, you get 0 plus 0. Second row, first column is 1 plus 1. Okay, and then this is 0 plus 1. 1, 0, 2, 1. Okay, this is a square. What will be a cube now? A cube is equal to a square into a, right? That is 1021 into a will be equal to 1011. Now if I multiply, I'll get this is 1 plus 0 and then you get 0 plus 0, 2 plus 1 and 0 plus 1 is equal to matrix 1031. Like this, if I take suppose a power n, this is 10n1. Answer is option C. This is clear, guys. You find out a square, a cube, and then you write directly a power n. Question number 81. Yeah, I told you, right, whenever in a 3 by 3 determinant, if our arrangement of numbers are in AP, then the value for determinant is always 0. It's equal to determinant of, if I change R2 to R2 minus R1, this is 101, 103, 105. If I subtract this, this will be equal to 3. Even this is 6, 5, this is 4. Alright, if I change C2 to C2 minus C1, okay, let me keep the first column as it is. 101, 104, 107. Okay, change C2 to C2 minus C1. You will get this is 2, this is 1, this is 1. And change C3 to C3 minus 101. This should be 102. Somewhere there's an error in this question. It's equal to determinant of you subtract, this will be 3, this will be 3, this will be 3. Change R3 to R3 minus R1, R3 minus R2. This is 3, this is 3, and this is 3. Okay, this should be 102, guys. Okay, there's a correction here. If I change R2 to R2 minus R1, this will be 3, this will be 3, this will be 3. Okay, so this is 102, 103, 10, 101, 102, 103, 4, 5, 6, 7, 8, 9. It should be 103. And then you get this is 101, 102, 103. Two rows are identical. Answer will be 0. Answer is option A. E1. Answer is option A only. Yes. Let's move to the next question. See, I can take, rather than you use that use the property and integrate. It's a 4-marker in the board exam. If it is true for ABC, then it should be true for any value of ABC. I'm going to take A is equal to 0, B equal to 1, and C equal to 2. So this determinant becomes determinant of A is 0, means this will be 1, this is 0, this is 0. Again A is 0, B square plus 1 is 2, BC will be equal to 2. AC is 0, BC is 2, C square plus 1 is 5. Delete first row, first column, you get 10 minus 4, which is equal to 6. Okay, now if I substitute in this, you get 1 plus 0 plus 1 plus 2 will not give me 6. So this option is ruled out. Similarly, this is 1 plus A is 0, BC is 2 plus 0, I'll get 3. Even this is ruled out because I need 6. I should get 6. 1 plus 0 plus B square is 1, C square is 4. You add all this, you get 6. Answer is option C. Right, question number 83. The inverse of this matrix is, if you find the determinant of this will be equal to 1. A inverse is equal to 1 by determinant A into adjoint of A. Determinant A is 1, right? Now I'll find the adjoint. Okay, center element you take, it will be 1. Below 1 I have C. Left out in this column is 0. Repeat the first element. Do the same thing for the last column. Center element is 0. Below 0 I have 1. Left out in this column is 0. Repeat the first element. 0, 1, 0 and then 0. Do the same thing for the first column. Center element is A. This is B and then 1. Repeat the first one. This is 1, C, 0, 1. Now adjoint will be equal to principal minus secondary is 1. 0 minus A is equal to minus A. If you go row wise, enter column wise. So this is AC minus B. Okay, again this minus this will be 0. Principal minus secondary is 1. Principal minus secondary is minus C. This is 0. This is 0. This is 1. Right, answer is option D. Okay, question number 84. Determinant equal to 0. First row will be equal to 1 plus A. This is 1 and 1. Change R2 to R2 minus R1. So this is minus A. 1 plus B minus 1 will be equal to B. This is 0. Change R3 to R3 minus R1. This is minus A. This is 0 and C. 1 plus A into delete first row, first column. This is BC. Minus 1, delete first row, second column. This is minus AC. Delete first row, last column is 0 plus AB. Okay, so this is equal to BC plus ABC plus AC plus AB is equal to 0. ABC, if I take common, this will be equal to 1 plus BC by ABC plus AC by ABC plus AB by ABC is equal to 0. ABC are all different from zeros, right? So this ABC cannot be 0 according to the question. So this is 1 plus 1 by A plus 1 by B plus 1 by C is equal to 0. So I get 1 by A plus 1 by B plus 1 by C is equal to minus 1. Answer is option A. Right, let's move to the next question. Question number 485. See, PQR are the roots of this equation, right? If I expand this, you get x into delete first row, first column, you get x square minus 4. Minus 1, delete first row, second column, you get x minus 2. Delete first row, last column, you get 2 minus x is equal to 0. x cube minus 4x minus x plus 2 plus 4 minus 2x is equal to 0. So you get x cube minus 6x x cube minus 7x plus 6 is equal to 0. Other roots should be found out using synthetic division. By inspection, x is equal to 1, right? Okay, by inspection, x is equal to 1. That because you get 1 minus 7 plus 6 will be equal to 0. So other roots should be found out using synthetic division. Let me take like this. This should be equal to 1, 0. Because there is no coefficient of x square. Coefficient of x is minus 6. Constant term is coefficient of x is minus 7. Constant term is 6. Initially write 0 and add. 1 plus 0 will be 1. Okay, this I will add. X is equal to 1 is the root. 1 plus 0 is 1. 1 into 1 is 1. Add, you get 1. You get minus 6. Okay, and then minus 6 plus 6 is 0. So this becomes x square plus x minus 6 is equal to 0. If I split the middle term, you get 3 minus 2. That is x plus 3 into x minus 2 is equal to 0. X is equal to minus 3. X is equal to plus 2. Right, now this PQR are the roots of this equation. So one root is 1. So these are the roots. Roots are 1, minus 3 and 2. You take in any way, no problem. So PQ are the roots, right? P is equal to 1, Q is equal to minus 3 and R is equal to 2. Or you can take in any way PQR. If I substitute here, 1 power 4 is 1, minus 3 power 4 is 81, R power 4, 2 power 4 is 16, P square is 1, Q square is 9, R square is 4. Okay, you get 82 plus 16 is 98. 98 divided by 14. Yeah, 98 by 14. So if I substitute 98 by 14, this will be equal to 7. Yeah, so answer will be equal to plus 7. Alright, let's move to the next question. Question number 86. A cube is equal to 0. What is I plus A whole inverse? See, this is not going to help me out. If I have, suppose A cube is equal to null matrix, A cube is equal to 0. I'll add I on both the sides. That is A cube plus I, okay, is equal to I. This I is same as I cube, right? Now A cube plus B cube. If you take A plus B out, you will get this as A square minus AB plus B square. A cube plus I cube, if I take A plus I out, this will be equal to A square minus AI plus I square is equal to 0. Okay, now this is A square, I into A is equal to A, I square is I. And right side I have I. Okay, if I shift this on the right side, you will get I divided by A plus I. You shift to numerator, you get A square minus A plus I is equal to A plus I whole inverse into I. Right, now if I multiply this, you will get A square minus A plus I is equal to A plus I the whole inverse into I is A plus I the whole inverse. A square minus A square minus A plus I. Answer is option C. Okay, question number 87. I am supposed to find out A into adjoint A. We know that A into adjoint of A is determinant A into I, right? So determinant A, if I find out, let's say this is matrix A. Determinant A is equal to, delete first row, first column. You will get 6 minus 6. Sorry, 8 minus 6. Plus 2, delete first row, second column. You will get 0 plus 9. plus 2 into delete first row last column, you get 0 minus 6. Okay, so this is 2 plus 18 minus 12, which is equal to plus 2 plus, this is 6, which is equal to 8. Okay, so this is 8 into 100 010 001. This is 800 080 008. Answer is option D. Right? Question number 88. See, this question is there in NCERT exercise only. If I change, suppose C1 to C1 plus C2 plus C3, number the same, positions are different. Either you add all the rows or you add all the columns. Now, if I add all the column 1, column 2, column 3, this is x plus p plus q. Even this is x plus p plus q. This is x plus p plus q. Second column will be equal to pxq. Last column will be equal to qqx. I take x plus p plus q out from the first column. Okay, and then this is equal to determinant of 1 1 1. This is pxq and this is qqx. Right, now this is equal to x plus p plus q into determinant of, keep the first column as it is, 1 pq. You change r2 to r2 minus r1 and change r3 to r3 minus r1. This is equal to 0 x minus p 0 0 q minus p, and then this is x minus q. Okay, so this is equal to x plus p plus q. If I multiply, delete first row first column, you get x minus p into x minus q. That's the first option only. Right? Question number 89. Determinant equal to 0. See, I'm going to change r1 to r1 plus r3 minus 2 times r2. So this is 0. This will be 0. R1 plus R3 is 2x plus a plus c minus 2 times R2 is 2x minus 2b. This will cancel. You get a plus c minus 2b. This I'll keep as it is. This is x plus 2, x plus 3, x plus 4, x plus 3, x plus 4, x plus c. So a plus c minus 2b a plus c minus 2b. Delete first row last column. You get x plus 2 into x plus 4 minus x plus 3 the whole square is equal to 0. This is a plus c minus 2b. This is x square plus 6x plus 8. If you open the bracket, you get a square minus 9 minus 6x. Anyways, this will be 1 or minus 1. This will cancel. This will cancel. Minus 1, right? Anyways, right side it is 0, exclude. So this becomes a plus c minus 2b is equal to 0. So this means that a plus c is equal to 2b. He's asking ABC is in what? So this means that ABC is in AP. Twice the middle term is equal to sum of the first term and the last term. ABC should be in AP. Okay, question number 90. I'll find out what is a square. A square is a into a, right? So this is 3, 2, 1, 1. This is also matrix 3, 2, 1, 1. Okay, now if I multiply first row, first column, this is 9 plus 2. First row, second column is 6 plus 2. Second row, first column is 3 plus 1. And second row, second column is 2 plus 1. A square is equal to matrix 11, 8, 4 and 3. Okay, now if I substitute here, A square is equal to 11, 8, 4, 3 plus x into A. So this is 3x, 2x, then this is x and x plus y into I, this y 0, 0, y, okay, is equal to 0. Now if I add, you get 11 plus 3x plus y is equal to 0. 8 plus 2x is equal to 0. Okay, and then 3 plus x plus y is equal to 0. From this 2x is equal to minus 8. 2x is equal to minus 8, x is equal to minus 4. So this is 3 minus 4 plus y is equal to 0, y equal to 1. X is minus 4, y equal to plus 1. Answer is option C. Even this will satisfy. Otherwise, no value of x will exist. Minus 12 plus 1 equal to 0. Yes, answer is option C only. Right? Question number 91. See, the question is limit x is tending to 0, fx by x square. It's a COMEDK problem. Okay, now listen. Limit x tending to 0. This is 1 by x square, right? This determinant will be equal to sin x. This is x cube and then 2x. There's a similar question in 21 or 22 paper. This is cos x, x square and 1. Then you get tan x, x and x. This is equal to limit x tends to 0 of. I'll multiply 1 by x for the second column. First column is sin x, x cube and 2x. First column, if I multiply 1 by x, this is sin x by x. This is x square. This is 2. Second column I'll keep as it is. This is cos x, x square and 1. Last column, if I multiply 1 by x, this is tan x. X by x is 1. X by x is 1. Now if x is tending to 0, sin x by x is 1. Get 1, 0 and 2. Second column cos 0 is 1, 0 and 1. Tan 0 is 0. Sorry, tan x by x is 1. Here if I divide the second column by x, so this is 1 and 1. Tan x by x is 1. 1 and then this is 1 and 1. This will be minus 1. First row, second column you get 0, minus 2. First row, last column you get 0. Minus 1 plus 2, which is equal to plus 1. Answer is option D. Okay, question number 92. If the determinant of adjoint of a real matrix of order 3 is 25, that is determinant of adjoint A is equal to 25. Determinant of adjoint A is 25. Determinant of adjoint A is determinant A power n minus 1 is equal to 25. N stands for order of the matrix, n equal to 3. Okay, now good afternoon, Gaurav. Now this is determinant of n is equal to 3, so this is 3 minus 1 is equal to 25. Determinant A square is 25. Determinant of A is equal to plus minus 5. Okay, I'm supposed to find determinant of the inverse of the matrix. Determinant of the inverse of the matrix will be equal to plus minus 5 whole inverse, which is equal to 1 by plus minus 5, which is equal to plus minus 0.2. That's last option D. Right, let's move to the next question. A is equal to matrix alpha 2, 2 alpha. Determinant A cube is equal to 25, 125. So this is same as determinant A whole cube is equal to 5 cube. So determinant A is equal to 5 cube is 5, right? Determinant of A is equal to alpha square minus 4 is equal to 5. Alpha square is equal to 9. Alpha is equal to plus minus 3. Answer is option D, C. Okay, now this is a COMEDK question. See, I can write this as 6x square minus x minus 1 divided by x into x minus 1 into x plus 1. Okay, here also if I take LCM, x into x minus 1 into x plus 1, you will get this as a into x square, x minus 1 into x plus 1 plus b into x plus 1 okay, and then c into x plus 1, x minus 1. This will cancel. Okay, so I get 6x square minus x minus 1. A into this is x square minus 1 plus bx square, or I can multiply here itself. This is ax square minus a plus this is cx square minus cx. Okay, now if I equate the coefficient of x square, you will get 6 is equal to a plus b plus c, right? If I equate the coefficient of x, left side you will get minus 1, right side you will get b minus c. And if I equate the constant term, minus 1 is equal to constant term is minus 1, right? You get a is equal to 1. A is equal to 1. If I substitute, you get 1 plus b plus c. Okay, b plus c is equal to 5. Now if I solve these two, b plus c is equal to 5. B plus c is equal to 5. B minus c is equal to minus 1. This will cancel. 2b is equal to 4. B is equal to 2. B is equal to 2 means 2 plus c is equal to 5. C is equal to 3. A is 1. B is 2. C is 3. Now if I substitute in this determinant, A is 1. B is 2. C is 3. A plus BC will be equal to 1 plus 6, which is equal to 7. You will get 7 minus 6, which is equal to 1. Right, answer is option B. Right, and the last, guys, 21, 22 questions are left out. In 21, 1, 2, 3, 4, 5, 6. 21, 6 questions were asked. 22 also many questions were asked. 1, 2, 3, 4, 5, 6, 7. 8 questions were asked in 22 paper. Okay, question number 95. This is 21 paper. See, first I'll find the roots of this equation. By inspection, x is equal to 2 only, which will satisfy this cubic equation. This is by inspection. Why you will skip Gaurav probability? You can go through it, na? You will get 1 or 2 questions right. By inspection, x is equal to 2 is the root, right? So you will get this as 8 minus 2 square is 4 minus 9 2 is 18 plus 18 will be equal to 0. So by inspection, x is equal to 2 is the root. Other roots can be found out using synthetic division. You get 1 minus 2 minus 9 plus 18. Initially write 0 and add. X is equal to 2 is the root. 1 plus 0 is 1. 1 into 2 is 2. Add, you get 0. 0 into 2 is 0. Add, you get minus 9. Minus 9 into 2 is minus 18. So this is 0. Roots are x square minus 9 equal to 0. Reduced equation, x is equal to plus minus 3. Now I'm getting the roots as 2, 3 and minus 3. Okay, now I should find the maximum value of this a. A is equal to 1 into 9x minus 6 8 48. Delete first row second column, 4 9 is 36 minus 6 7 is 42. Plus 3, delete first row last column, you get 32 minus 7x. You will get 9x minus 48. If it is minus 6, so this is plus 12. This is 96 minus 21x. Okay, this will be equal to minus 36, right? Minus 36 means 60 minus 12x. This is a. This fellow will be maximum. I'm getting 3 roots, 2, 3 and minus 3, right? So this will be maximum at minus 3 only. A maximum is equal to 16 minus 12 at x is equal to minus 3. At minus 3 only you get maximum value. At this value, that is 36, which is equal to 96. Answer is option A. Okay, again this is this is 2021 paper. This is KCET 2021. Okay, very simple question. AB whole transpose. AB whole dash is equal to B dash into A dash. That is reversal law of transposes. B dash will be equal to 2 1 3 2. Take the transpose of B, 1 1. A dash is equal to 1 minus 2 and 1, 2 1 3. Now if I multiply first row first column, you get 2 minus 6 plus 1. That is first row first column. First row second column, you will get this as 4 plus 3 plus 3. Second row first column is 1 minus 4 plus 1. Second row second column is 2 plus 2 plus 3. You get minus 3 plus 10 minus 2 and then 7. Answer is option B. Okay, question number 97. Even this was asked in 2021 only. KCET 2021. Okay, I should check which of the following is true. M is invertible when which of the following is true. Invertible means inverse should exist. M is a symmetric matrix of order. M is a symmetric matrix of order 2 with integer entries. That is, if I take this as A, B, this is A, this should also be B, because in a symmetric matrix, elements which are symmetric to the principal diagonal should be same. Okay, now option A, the first column of M, the first column of M is the transpose of second row of M. Transpose of second row of M will be equal to BA. Principal, can take this as A, B, C, na? You take anything in the principal diagonal, I'll take this as A, B, C. Okay, and elements which are symmetric to the principal diagonal should be same. It is like M transpose should be equal to M because it's already mentioned it's symmetric matrix. Now according to the question, the first column of M is the transpose of second row of M. Transpose of second row of M is BC. If I equate, you get A is equal to B is equal to C. If A is equal to B is equal to C means determinant M is equal to 0, so inverse does not exist. This is not possible. Similarly, option B, the second row of M is the transpose of first column of M. Transpose of first column is AB. That is, A is equal to B is equal to C. Again, if I equate, determinant M equal to 0, so inverse doesn't exist. Even this is false. M is a diagonal matrix. M is a diagonal matrix with non-zero entries in the principal diagonal. Yes, Principal diagonal elements to take non-zero. M is a diagonal matrix with non-zero entries in the principal diagonal. This should be 0. Then obviously inverse will exist. If M inverse will exist. Okay, and the last one, product of the entries in the principal diagonal of M is equal to product of the entries in the other diagonal. Product of the entries in the principal diagonal is equal to product of the entries in the other diagonal, means AC is equal to B square. Again, determinant M equal to 0. Inverse doesn't exist. This is also false. Answer is option C. This is 2021 problem. Okay, question number 98. If you take 3 outside, this is 3 power n. Determinant A into determinant B. N stands for order of the matrix. It's a matrix for order 3. So for n is equal to 3. This is 3 cube. Determinant A is equal to 5. Determinant B is 3. So 27 into 15, which is 405. Answer is option B. Right, now I should check which of the following is incorrect. This is correct because determinant A inverse is same as determinant A whole inverse. Even this is correct. Okay, so this is correct. Even this is correct. I should identify which is not correct. AB whole inverse is B inverse into A inverse. Reversal law of transposes. Yes, Gaurav, right. This is incorrect. First is also right. A inverse is equal to 1 by determinant A into adjoint of A. If you cross multiply, you get A inverse into determinant A is equal to adjoint of A. So first is also correct. Even this is correct. The only last option is false. Okay, now x is tending to pi. Fx is equal to, delete first row first column, you will get this as cos x 4 cos square x minus 3 minus 1, delete first row second column, 0 0 multiplied by finite quantity is 0, this is 0, this is 0. You will get 4 cos cube x minus 3 cos x. 4 cos cube x minus 3 cos x is cos 3x. Now this is limit x is tending to pi and you get cos 3x, which is cos 3 pi. Cos 3 pi is equal to minus 1. Right, answer is option A. Right, yes, only last 22 questions are left out. This was asked in KCET 2022. Right, determinant of an is equal to 1 minus n the whole square minus n square. Now determinant of a1 is equal to 1 minus 1 the whole square, 0 minus 1 square, this is minus 1. Determinant of a2 is equal to 1 minus 2 the whole square minus 2 square, which is minus 3. Similarly, determinant of a3 is equal to 1 minus 3 the whole square minus 3 square. So we get 4 minus 9, which is minus 5. So if I substitute here, this is minus 1, minus 3, minus 5, and so on up to 2021 terms. Okay, so I take minus common, you get 1 plus 3 plus 5, and so on up to 2021 terms. Okay, so obviously this is an AP, right? This is an AP. So sum to n terms of an AP, yes, Gaurav, right, is n by 2 into 2a plus n minus 1 into d. This is 2021 by 2 into 2a, that is 2 into 1 plus 2021 minus 1 into difference is 2 minus 2021 by 2, take 2 outside, it is 1 plus 2020. will cancel, and if I multiply, this is minus 2021 the whole square. Okay, answer is option A. I should find out what is inverse of a cube. A square is equal to 2 minus 1, 2 minus 1, 3 minus 2. Even this is 2 minus 1, 3 minus 2. First row, first column, I'll get this as 4 minus 3. First row, second column, you get minus 2 plus 2. Second row, first column, you get 6 minus 6. Second row, last column, you get minus 3 plus 4, which is equal to 1001. Now, a cube is equal to a square. This is same as I. A square into A. A square is I into A, which is equal to A only. Answer is option D. Right. If A is a skew symmetric matrix, skew symmetric matrix means a matrix which is equal to negative of its own transpose. Okay, so I get A 2021, A to the power of 2021 transpose. This is same as A power T whole power 2021. This is minus A whole to the power of 2021, which is equal to minus A to the power of 2021. So it is equal to negative of its own transpose. So this means that A power 2021 is a skew symmetric matrix. If it is equal to its own transpose, then it is symmetric. Negative of its own transpose is skew symmetric. Even this was asked in 2021. Right? Even this was asked in 2021. Hi Guru Raj. So this is AI plus BA, right? A into I is equal to 1001, right? And then B into matrix A will be equal to 0, 1, sorry, 1001. This is 0, 1, 0, 0. Now let's multiply this. This is A00 A, right? And this fellow will be equal to 0, B0, 0. Now if I multiply, this is equal to A. Okay, this is A plus 0 is A, and then this is B. Right, and then this is 0, then this is A. If I take suppose AI plus BA the whole square, this should be equal to A plus AB 0A. Again, this is equal to AB 0A. Okay, now if I multiply this, this should be equal to A square plus 0, and then you get this as AB plus AB is 2AB. This is 0, and then you get this as A square. See, actually this fellow will be equal to, this is A square into 1001, okay, plus 2AB into 0100. You add this again, you get back the same thing. Right, so this is equal to A square into I plus 2AB into A. Similarly, if I take suppose AI plus BA the whole cube, if I take, suppose this is this fellow is A square 2AB, this is 0 and A square. Again, this will be equal to A, right? AB 0A. So this is equal to A cube. A square B plus 2A square B is 3A square B. Okay, so this is 3A square B, and then this is 0, and then the A cube. This is A cube into matrix 1001, right? Plus 3A square B into 0100. This is A cube into I plus 3A square into B into A. Like this, if I write up to power n, similarly based on the observation, this is AI plus BA whole power n. Whole power n. this would equal to a to the power of n into I plus 3 into a to the power of n minus 1 into b into a. Right, answer is option A only. Right, question number 105. See, if I take 5 outside the determinant, it is 5 power n into determinant of adjoint A is equal to 5. N stands for order of the matrix, right? N is equal to 3. So you get 5 cube. Determinant of adjoint A is determinant A per n minus 1 is equal to 5. N again, n is 3, so this is 3 minus 1 is equal to 1 by 5 square. Now determinant A is equal to plus minus 1 by 5. Answer is option B. Yes, Gaurav, right. Yes, Guru Raj, I live in Bangalore only. If I expand this, you get 1 into delete first row, first column, you get 2a square plus 4, right? Plus 2 into delete first row, second column, you will get 4a minus 0. I'm not copying anything, dude. I have nothing with me. Guru Raj, why will I copy from the other book and all? These are all KCET questions, simple problems, man. I am writing on the what do you say, notepad. Come on, dude, grow up, man. Copying it seems. My pen tablet is like that. I should bend and write. Delete first row, first column, 2a square plus 4 plus 2 into, this is 4a minus 0 plus 5 into delete first row, last column, you get 8 minus 0 is equal to 86. All crazy, guys. 2a square plus 4 plus 8a plus 5 8 is 40 is equal to 86. 2a square plus 8a, alright, and then you get 86 and 44, which is 42. Right, if I divide by 2, if I divide throughout by 2, you will get this as a square plus 4a minus 21 equal to 0. If I split the middle term, 7 minus 3, which is 4, multiply, get 21. So this is a plus 7 into a minus 3 is equal to 0. So if I expand this, you get a is equal to minus 7 and a equal to plus 3. Is asking what is sum of the values of a. Sum is equal to minus 7 plus 3, which is equal to minus 4. Right, answer is option D. Okay, and the last one, this was asked in KCET 2021. Area of the triangle, this you will do in boards only. Area is equal to half of determinant of x1 y1 1, x2 y2 1. This is x3 y3 1. So this is equal to half of determinant of x1 y1 1 is minus 2 6 1, 3 minus 6 1, 3 minus 6 1, and 1 5 1. Delete first row, first column, you get minus 11. Delete first row, second column, you get 3 minus 1 is 2. And then you get 15 plus 6 is 21. Okay, half of this is 22 minus 12 plus 21, which is 31 by 2. 31 by 2 is 15.5 square units. Answer is option E. Right. Anyway, I'll stop here, guys. We will continue with the next section with session with other videos. All right, other MCQs. If you haven't subscribed, please do subscribe. Enable the bell icon. If you're already subscribed, please share this video. All right, and please go through the description box, guys. Thank you, guys. Thanks for joining.